Hello and welcome to EE 233. I'm your instructor, Gregory Myers. In this video, we're going to take a look at three additional functions that I have provided now in our core.h. And we're going to go through the steps now to complete these functions and to add them then to our test or our core driver.c. So our first step is to note what the function signatures are going to be in the core.h. And if I get a chance to, I'll also provide these in the comments for the YouTube video. Unfortunately, though, YouTube does not allow for me to necessarily have certain characters in the comments field. So we'll give this a shot. And if I can, I'll add them there. But if not, just pause the video for just a second and add these three functions to your core.h. So once you've done that, you want to go ahead and make a copy of those function prototypes, and you want to add them then to the bottom of your core.c. So we'll go ahead and add them here. We'll remove the semicolon at the end of each one of the functions, expand it out then using the curly braces, and then a couple of other little minor things that we want to do. We want to go ahead and maintain the same pattern for the comments for the documentation. I'm going to allow for you to expand this out as you see fit. But we want to at least have the name and then the description fields for the comments for each one of our functions. So go ahead and take a second to go ahead and stub these in. And then the last thing that you want to do to get us started is going to be to provide then the result value. If you notice that in each of these cases, I have an integer return value. Now we got a couple of options. So these functions are very similar in their behavior, or at least similar in the algorithm that we're going to use. We are going to be passing a vector to them. It's going to be a double. In the first example, we're simply just going to get the maximum value in the vector. The second function, we're going to get the minimum value in the vector. And then the third one, we're going to get the mean or the average for the vector. Now, notice my return type is an integer. So your first thought would be, well, why not just simply make that a double, and then we could return the value then that would be either retrieved or calculated. Rather, what I want to do is I want to use the return value as a status value, meaning that I'll say whether or not the function has executed successfully. And instead, what we're going to do in each of these three functions is we're going to use a by reference variable, or in the case of the first two by reference variables. So nonetheless, then in each one of these three examples, then what we want to do is we want to provide a results variable, which we are simply going to initialize to 0, or you could also simply put in exit success. Either is fine. And then you want to simply return your results. And once again, we're doing this up front because we want to sort of treat this as a recipe for these functions. So I'm going to go ahead and stub each one of these in. And then you can go back and you can add the name and the description for each one of these functions. For this video, we're going to jump into how to do these. So we're going to focus first on the get max vector. And the idea with the get max vector is it's going to loop through each one of the elements, looking for the largest value. And as you can imagine, then the get mean vector does something similar, except it's going to be looking for the smallest value. And so in order to accomplish then what we want to do is we want to have a couple of temporary variables. The first one is going to be another integer, and we're going to call this n index. And what that's going to do is it's going to allow us to loop through the vector, starting with the value 0 and looking at each one of the values in the vector. And you'll notice then we have a n value at an n location. Well, the n location is going to be the location of that largest value. And so what we want to do is we want to utilize these two by reference variables to then update back to the calling function the maximum value and also the maximum location. Now, truth be known, we could have gotten away just with the maximum location and we could have then checked against the original vector. But in this case, I wanted to actually provide both of those pieces of information back to the calling function. So we want to remind ourselves that n indicates the number of elements in our vector. And so that in C, we must pass this value here in order to be able to know when to stop looking through our vector of doubles. In order also to make sure that we get a value, we want to check to see how big the vector is. In other words, we want to check values of n. And so looking at some edge cases, the first one is if n is less than or equal to 0. So if n is less than or equal to 0, that essentially means that for some reason, whatever function called our getMax vector didn't pass it a vector that had any data in it. So in that particular case, then the first thing we want to do is we simply want to say results equal to exit failure, because the function never actually got a vector to iterate through. Now, the other argument that you could make is that we should distinguish between n equal to 0 and n less than 0. But in this scenario, I view as a vector that's equal to 0 as essentially unable to be iterated through, and therefore there is going to be no max value and then no max location. So the next condition is going to be if our n equal to 1, and if n is equal to 1, then we've actually got sort of a simple example here, and that is going to simply be that our n location is going to be equal to 0. In other words, that's the index in which the highest value resides, as well as the largest value itself is going to simply be equal to whatever value is located at that 0th location. So basically what we would do is in this scenario is we would assume then that there is only, since there's only one value in that vector, that it is in fact the largest value. Then under the else, this basically just leaves the scenario where n is in fact greater than 1. At that point, then what we can do is we can utilize a temporary variable. In this case, what we're going to do is we're going to come up here, we're going to create a temporary variable of type double, and we're just going to call it max. And in this case, what we do is we assign the first value in the vector to the max variable. And from there, what we do is we simply use a for loop to loop through each of the values in the vector, starting with n index equals to 0. And we continue while n index less than our n, which is the total number of values in the vector, and we increment by 1. And from there, what we do is we compare each of the values in the vector to that original max value. So we say then if the value at the location in the vector indicated by n index, if that in fact is greater than the previously held max, then effectively what this means is we have found a new max. In which case, then we simply say max is equal to vector square brackets n underscore index. And we also want to keep track of the corresponding index, which would mean that we would probably want to go ahead and grab then another temporary variable. In this case, it would be an int, and what we would call here then is max index or max location. All right, so then here what we would do is max underscore location is going to be equal to n index. Now, at this point, then under the else branch, we would simply move to the next location or keep looking. And so outside of the if statement, we would simply then increment, or rather, let me rephrase this, then we would move to the next location in the vector by virtue of this being a for loop. If it was a while loop, we would increment the index. Now, a couple of things should be bothering you at this point as you're looking at this code. The first thing that should bother you is the fact that if we start at index equal to 0, and we already said that the max value is equal to the value at the 0th location of the vector, then essentially what we're doing is we are comparing that value to itself. And so we instead do not have to start off with the n index equal to 0. Instead, what we can do is we can start off at n index equal to 1. So essentially what we'll be doing is we're going to be comparing the second value to the first. So that's going to alleviate one problem here. The second thing you should note is that we in fact have a little bit of redundancy here, meaning there's nothing wrong with the code that we've just written. However, we could collapse the else if and the else into one branch. And to see what I mean by that, we're actually going to go ahead and combine these two. We're going to eliminate this else if, and we're going to eliminate this else, and I'm going to do a little bit of refactoring here. So in other words, I'm going to eliminate the n location and the n value, and instead now let's think about this scenario where we have our n is going to be greater than or equal to 1. So we already know that if n is 1, basically there is going to be a 0th element in our vector. So we set that to max. And then if we go from n index equal to 1 and we compare then n index less than n for our condition for our for loop, if n is 1 and n index is 1, this criterion or this condition right here will immediately return false, in which case this for loop will never run. And so as a result, we could technically collapse our if else into simply two conditions, one where n is less than or equal to 0, and then everything else. Now, at the end of this, basically under the else branch, in other words, if we do know that in fact we had one or more values, what we can do now is we can assign whatever value is found to be the largest to our n value, and then the location or the max location to the n location. The order of which you do this doesn't really matter. As a matter of fact, as I mentioned earlier in the video, technically there's a little bit of redundancy in this one, and it's just for convenience. But basically what we would do is for the value, we would assign whatever we captured as the max, and then for the location would simply just be that max location. Note here that I'm using the asterisk or the indirection operator to basically indicate that we are modifying the value at that location. And we return the results. Remember that we aren't technically returning the n value in the n location, but rather we are updating the value at that location. And so why don't we give this one a shot here? So the first thing we want to do, we'll go ahead and save this. We're going to come over to our core driver. And as we've done in earlier videos, we want to test a particular function. We can do the setup inside of the else if branch. But what I'm going to do is I'm going to scroll down here to the bottom, and we're going to keep our function name. In this case, we were looking at our get max vector. We're going to use that as a switch. So we'll come all the way down here to the end of our rather long main at this point. We're going to throw in another else if, and we're going to keep the pattern that we were doing in our earlier videos, where essentially what we were doing is we were checking the arg count, and if argc was simply equal to not only the executable, in other words, argv held the executable, but also a switch. So if argc was equal to 2, and then using string compare I, or argv square brackets 1, simply matched the switch get max vector, we're going to do all the setup inside of this if else if branch here. So in other words, if this is going to be equal to 0, then at this point, what we're going to do is we're going to just simply go ahead and declare a vector here. We're actually going to do 2 examples here because we want to test the edge cases as well. We're going to assume that we only have a single value in our vector. So we'll begin here. We're going to create a vector of doubles. We're going to call it a sample. We'll go ahead and put 10 values in it, but we're not going to completely fill it up. Or not in every one of our examples are we going to fill it up. We're going to go ahead and initialize it, though, using a for loop. So we're going to need an index here. We already have a temporary variable up here that we've been utilizing over and over again. That's our index variable. We're not going to be very creative in what we initialize this with, so we're just going to do a for loop. So for index equals 0, index less than 10, index plus plus, and I'm just going to say sample square brackets index now is going to be equal to whatever that index is. Now, this is going to store it as a double, and what we want to do now is we want to pass using the results variable using our function. So results is going to be equal to get max vector. We want to pass to it our sample. We want to specify how many values we expect in our sample vector. We're going to start off with the edge case of 0. We need to provide it 2 more variables. One is going to be our end location and our end value, both of which are going to be passed by reference. So n underscore location and ampersand n underscore value. Which means we're going to need these 2 temporary variables here. So we're going to start off here as the location is an int, so it's going to be int. It's going to be a pointer to an int. We're going to call that one location. Actually, we're going to pass it by address. So in other words, we can simply use an integer variable rather, and then a double of n value. Now, if the results are equal to exit success, what we want to do is we want to print out the max value, spelled success there, the max value occurred at, and why don't we give a couple placeholders here, the max value of percent f occurred at %d. And for the %f, we want to specify whatever the value is. And for the %d, we want to specify the location. And then under the else, how about printf error, no max value was determined. All right, so let's give this example a shot. We're going to go ahead and build it. We're going to go ahead and fire up our command line. We're going to change to the correct directory. In this case, I'm going to be in my core demo, in my distribution folder, in my debug, in my min.gw, and you should see now our core_demo.exe. And what we want to do is we want to pass to it now our switch of get max_vector. And you'll notice here it says error, no max value was determined, because we specified that the vector was 0 length. Now, if we specify that our vector, I'm going to just simply copy, paste this down. If we specify that it has a single value in it, then it should only look at the first value. So we'd expect the maximum value then to be returned at index equal to 0, and the value would be 0. So if we run this again, you'll see that says the max value 0.00 occurred at 0. This is probably a great opportunity for us to clean this up a little bit. How about if we say something like at index equal to %d. Once again, these are just niceties. You could also say location, etc. And now what we want to do is we want to try the real example, the one that we're really interested in. And it is, what if we specify that our sample vector actually has 10 values in it? So I'm just going to leave the previous examples in there so you can see them, play around with them. And then now if we rerun this, you'll see that it says the maximum value is actually 9, and it occurred at index equal to 9. All right, and once again, that kind of makes sense. Now, just to prove that there's no magic going on here, I'd like to make a little change in my initialization here. So I'm actually going to change my sample square brackets index equal to index minus, and I'm actually going to subtract 5 off of it. And 5 is, I guess you could say, kind of arbitrary here, but the idea is I wanted to show that we have both negative and positive values, and that's going to matter then in the next example as well. But if we rebuild this one more time, you'll see that the max value of 4 occurred at index equal to 9. And so you'll see that it isn't just erroneously mapping then the index to the value. It's actually pulling out the value at that specific location in our vector. All right, so now what do you think we do differently in our other example here? So sorry, scroll down in the wrong file here. Let's get back to the place we were at. If we go over here to our core.c, how do you think the get min vector changes from the get max? Well, the reality of it is there's not a whole lot of change. As a matter of fact, you can actually go ahead and borrow a sizable amount of this code, and we can come down here to our get min vector. And really and truly, the only thing we need to do is change some of our variable names. How about if we change this to min and min location? All right, so we'll go through, and everywhere we had a max, we want to change it to min. But then, more importantly, what you want to do is after you've made all of these changes, you want to decide what's really different about the logic or the algorithm. And the answer is not a whole lot. As a matter of fact, once you get all of your changes made there, if you think about it, the only thing that's really different is the sign here. So in other words, instead of checking to see if our vector square brackets and index is greater than, we simply want to say, check to see if it's less than. And if it's less than, we found a new minimum value. At that point, then we can simply go back to our core driver, and you can go through the trouble then of creating another branch here of our if statement. And that's perfectly fine. As a matter of fact, we could just simply duplicate all of this and change once again everything from the max now to min, and everywhere we have max, just simply change it to min. And min. All right, now let's go through our examples one more time. So I'm going to uncomment the first one. I'm going to comment back the second and third one. We're going to go ahead and build this. And I'm going to just change our switch here from get max vector to get underscore min underscore vector. And you'll see that when a 0 length vector is passed, you're going to get a error, basically by virtue of the fact that results is going to have exit failure in it, and no min value was determined. So let's change this now. Let's get a result from a vector, in this case, that had a single value in it. Once again, we run it, and you'll see now the min value is -5, and it occurred at index equal to 0. Why is it -5? Because we actually have a shift here that we've created on our little sample vector. And then the final example here in this run, we build this. And we rerun this. The min value is -5, and it occurred at index equal to 0 because all the rest of the values that came after index equal to 0 were larger. So it seems like our algorithm is working well, which leaves us then with the third function that we wanted to handle in this video, and that is our get mean vector, or in other words, just simply the average. And so in this particular example, what we want to do is we want to create a temporary variable that is going to sum up all of the values in our vector. And then what we want to do is we want to return whether we had success or failure. But what we also want to do is we want to update whatever the value was after we calculated the average. So we want to sum up the total of the vector, or we want to create the total vector, sum the vector, and then we want to divide it by the number of elements in that vector. So we could actually create another helper function called getSum. That probably wouldn't be a bad thing to do here, but in this case, what we're going to do is we're going to roll it all into one. Based on the previous functions, the first thing that we want to do is we want to check to see how many elements are actually in the vector. So in other words, if our n is less than or equal to 0, we have a problem. And so at the very least, what we want to say is results equal to exit underscore failure. You could technically have put an error or warning message in here. That would have been perfectly fine. But then under the else, we actually want to do some calculations. And those are going to start off with summing everything up. And so we want to go ahead and create a temporary variable called sum. We want to initialize it to 0, such that what we're going to do now is in our for loop. So we actually need one more temporary variable here. Our int n index, like we used earlier. So for n underscore index equal to 0, n underscore index less than n index plus plus. And what we want to do is we simply want to sum whatever the value is at that particular location in the vectors. So vectors, square brackets, and underscore index. And we simply add it to whatever that temporary variable is. So what we have here is essentially a temporary variable that just simply sums up an aggregator variable here that just sums up the values. And then once we're done summing up the values, so in other words, we've exited out of the for loop, then we can simply calculate the mean by using the sum. And then more importantly, what we want to do here is we actually want to cast to a double the integer n. All right. And then at this point, we should have updated our n value based on the sum of the vector divided by the number of elements in that vector. And once again, we can have the same discussion as we did earlier about simply having a double return value. We had a double return value. We could have simply returned the average or the mean rather than having to pass another variable by reference. I like this approach a little bit better because it allows for you to essentially use the return value upstream in your logic, meaning that you can do some error handling if there is an issue with your get mean vector. So for instance, if some reason it fails or if it was passed data, you don't, an empty vector, you don't have to do that error checking outside of the function. You do it inside the function. Of course, it would also be a good idea to do it outside the function, but in this case, you validate the data inside the function, and the results variable is used to tell you whether or not the function successfully ran. And the only penalty, of course, is that you have an additional, in this case, by reference variable. All right, so let's go ahead and save this, and let's go up here to our core driver. And let's go ahead and try to do this one. Now I'm going to go ahead and borrow some code from the earlier example. In other words, the else if argc equal to 2. And what I'm going to do is I'm going to change that last part, the second condition there, and I'm going to change it to get mean vector. And we need a couple of more temporary variables, just like we did before, though not all of the ones. So we're going to type some of this back out here. We're going to say a double sample square brackets 10. We can go ahead and initialize our sample much in the same way that we did the last time. Although in this case, what I'm going to do is I'm going to start off and go from 0 up to 9. So we'll say for index equals 0, index less than 10, index plus plus, and we'll simply say sample square brackets index equals to index. And the idea here is then once again, we use our results variable, and our results are going to simply be equal to get the mean vector we want to pass to it, our sample. We're going to go ahead and specify that it has 0 values in it. And for the by reference variable, we're going to use the address of n underscore value. Now that means that we have to create one more temporary variable. No big deal. We'll simply double n value. All right. And once again, because we can now check the logic here. So if results equal to exit success, what we can write here is maybe something like printf the average, and then we're going to specify is %f for %d values. In other words, we're going to provide to it two pieces of information. One is going to be the value in n underscore value. That's actually going to be the first placeholder. And then for the second placeholder, I'm going to just hard code this as 0. In other words, it's going to be the number of values or number of elements in our vector. So actually what we'll do here is we're going to just temporarily, we're going to create one more variable. We're going to set, use it n here so that we don't have to do this several times or comment out like we did in the earlier examples. We're just simply going to specify an n, and that way we can reuse it now inside of our if statement. Under the else branch, then we simply want to printf error no mean value was determined. All right, so far so good. Basically, in this example, as opposed to the other one where we commented and uncommented outlines, we can just simply control it then based on the n. So we're going to change our n from n equals 0, 1, and then ultimately up to 10. All right, so let's go ahead and build this. Let's see how this one works. And we're going to get mean vector. And you'll see here that it says no mean value is determined. If we change this to 1, the average is 0. Why? Because the 0th element was 0. There was only one value in that vector, even though we declared it to be 10 values. We initialized it to 10 values. We ultimately decided to only use the first value. And then the last example is if we change n equal to 1 to n equal to 10, then basically what we would do is we'd sum up 0 through 9, and we would divide it by 10. And you should see that the average is 4.50 for 10 values. And that's really not that surprising if you've done it quickly on a pencil and piece of paper. With a pencil and piece of paper, you have discovered the same thing. So hopefully you've found this little suite of functions a useful addition to your core.c. We're going to continue to add to our list of functions in our core.c, but our get max vector, get min vector not only can be useful in the future, but also demonstrate logic of comparing a existing max or min to all of the other values in a vector. And then once a condition is met, simply updating that temporary variable. So we'll use this approach also in our sorting algorithm. And then our get mean vector or get average vector is just simply a useful tool, not only for averaging a, in this case, a vector of doubles, but can also be used in the future for averaging values in a array of structures. So once again, hopefully you found this video useful. As always, if you have any questions, don't hesitate to ask me. And thank you for watching.